I'm going to talk about the architecture of Ultra Archive Plus and Ultra Vision with the goal of showing you not only the architecture of the product, but how we can make those products redundant or use them in a redundant architecture. So we start with an Ultra Archive or an Ultra Archive Plus, and we obviously have a client that wants to send data or pull data from that Ultra Archive Plus, typically DICOM data. In between of, we're going to have a firewall or a router or, all of those things, and we somehow, create this connection between the client and the archive. Usually it's a VPN between the client and the Ultra Archive. So basically, the client is going to send a DICOM file. You can see here a conceptual diagram of a DICOM file. You've got the actual image data in a DICOM file, and then there's metadata which describes that file. And you can see here that metadata is much more detailed than you would normally find in an image file, like something you might see in a JPEG or a bitmap or TIFF or something along those lines. So it's definitely much more detailed. There's a lot more metadata in a DICOM file, and necessarily so because we have to store information about the patient, the study itself. So all those details can be found in the DICOM file itself, all contained within that file. So that file that's on the client system, usually in their packs, they're going to transmit that file to the Ultra Archive through something like a VPN, and it's going to arrive at that Ultra Archive. Once the Ultra Archive receives the file, it's going to process the file by converting the transfer syntax or the compression of the file to something that's standardized. So however we received it from the client, we're going to normalize that to however we're storing the data on the drive architecture, and then we're going to put that file into the file system itself. We're also going to strip off the metadata, and we're going to put that metadata into a SQL Server. We're probably going to be storing millions upon millions of files in that drive architecture. It would be very difficult to search and manage those files strictly from the file level. So we need a database server to track all the information that's stored on the drive, and we use just the metadata in the database, not the actual images. So that's the basic architecture of an Ultra Archive or Ultra Archive Plus. And to pull a study back to the client, you can reverse what I just showed you, where we can search the metadata on SQL Server, and we can pull the files from the drive architecture and send a DICOM back to a client. For the and by the way, SQL Server would also have its own drive architecture, which we'll talk about in just a moment. For the Ultra Vision server, its job is sort of the opposite of the Ultra Archive, where Ultra Archive spends most of its time collecting data that people send to it. Ultra Vision is spending most of its time presenting that data to the client, and typically that's in a web browser. Although it can also facilitate the creation of soft CDs and virtual CDs using the Ultra Archive as well. But as just from a basic scenario standpoint, our client does opens up a web browser, brings up the UltraVision web page, and conducts queries to find the data that they're looking for. Those queries are happening in the SQL Server. Once the client locates a file that they would like to view, the UltraVision server will find the file on the hard drive or on the drive subsystem. That file is pulled to the UltraVision server where it's processed. In the processing, it's typically going to remove the metadata and convert that into a standard JPEG file that's natively viewable in a web browser like Chrome, Firefox, or Internet Explorer. That file is then viewed by the client on the client side in a browser. And again, this can also, the client can also pull the file back as DICOM from the Ultra Archive. It doesn't necessarily have to be non-DICOM from UltraVision. But that's UltraVision's primary job, but it can also mediate creating the soft CDs and the virtual CDs using the Ultra Archive. So this is all great, makes a lot of sense, but the problem is we have no redundancy here. So if we lose our Ultra Archive software, the application server for either Ultra Archive or Vision, obviously all those services are unavailable. If we lose our drives, the services are unavailable. If we lose the SQL Server, services are unavailable. So we want to work in some redundancy on here, and we can start that process of redundancy by putting in more than just one UltraVision and Ultra Archive server. The other piece is we would want to probably have multiple hard drive subsystems. So maybe a SAN that's multiple arrays of drives, or NASes that's multiple arrays of drives. And same thing on the SQL Server. We probably don't want one single location for those SQL Server files. Usually with a SQL cluster, you shadow the SQL files in multiple drive subsystems like SANs or NASes and things like that. So what we introduced to this workflow, that's a big part of it, is going to be the load balancer or content switch. So our client, when they make a connection to this data center, they only see one IP address, whether it's for UltraVision or for UltraArchive. And they're really only connecting to one host name or one IP address from the outside world. And they don't really have to know about what's happening inside the data center. Everything you see from the load balancer to the left, all they have to know is that outside IP, and as long as that load balancer is operational, everything appears to be online to the client, regardless of what's happening inside the network. So of course that load balancer has redundant, has connections to all of the UltraVision, UltraArchive servers, and it's going to round robin the traffic. So all web traffic we get round robin between UltraVision servers on port 80 or port 443, so the typical web ports, and on the UltraArchive side, typically we round robin either port 104 or 11112, but those ports are at the discretion of our customers that implement these products. So so certainly for the web and for UltraArchive, you could use any port you like, but the standard ports, of course, for DICOM is 11112, and for web is going to be 80 and 443. And some customers don't do 80, they just do 443 because they only allow HTTPS, but we can redirect to HTTPS on the UltraVision servers. On the back end of the workflow, so again, the UltraVision and the UltraArchive is what faces the customer. The customer doesn't interact with any other, the client side does not interact with anything other than the UltraVision and the UltraArchive servers. But on the back side, we've got the drive architecture, which of course the UltraVision and the UltraArchives would both have a connection to, and they would probably be redundant connections, and they can all talk to the SQL server. So we have these redundant connections to the multiple SQL servers. That could be, so for the SQL servers, it could be a clustered SQL server. It could just be two SQL servers with some kind of manual failover process. Our software does facilitate that manual failover process, though it's not as clean as having a SQL cluster, which is all automatic failover. Of course, automatic failover is always better. And the load balancer gives you that automatic failover between the UltraVision and the UltraArchive servers, the multiple servers. And of course, the SQL servers would have redundant connections to the drive architecture that they use, which, again, with something like a SQL cluster, that's all standard configuration stuff in Microsoft, where you configure the access to the multiple drives. So this is basically an overall what the workflow looks like. It almost looks like the Star Destroyer from Star Wars, but basically this is what we consider to be a redundant architecture for our products. And if you have any questions on how to configure this, or any more questions on the details of how to implement this type of redundancy, please reach out to us. Thank you.